I'm Akshaya from Acharya, and let's get started. Common UI problems. Now, everyone here is familiar with JavaScript fatigue. There's churn in the ecosystem constantly. We've been through REST. GraphQL came along, gave us amazingly structured APIs with types. TRPC came along and went, a little too complicated. We'll go back to REST and add types to it. State management has its own chapter. We have client libraries. We had fetch API for REST. GraphQL request. Apollo came along, added a few more features. And TRPC is player in the game as well. So for a toy application or a small application, this is really okay. Because at the end of the day, whichever choice you pick, you're actually going to get the output you want. You're going to get stuff done. But as your application grows larger, and if you're the guy actually responsible for shipping product, a lot of teams come across the same implicit kind of issues that are just under the surface. And building the Acharya console at Acharya, we sort of noticed problems happen as we scaled up our UI application. And we noticed velocity and iteration speed went down. We noticed that every developer added, the output didn't actually scale as we expected. We noticed that every developer added actually had to learn a significant portion of the code base to actually even make small changes. Bugs, stuff broke all the time. And that sort of leads to developers being less confident to actually go ahead and make those changes in the first place. So people have thought about these patterns, and you might have heard things like micro apps or micro front ends. And the thing is, just like Backbone and later on React.js solved our spaghetti problem with our PHP and jQuery, what does that solution look like when it comes to data fetching? And that's what we're going to look at. So, hey, you have components that encapsulate your state and logic. You might think, okay, that's simple. We're just going to take our data fetch, and every component is just going to fetch the data that it needs. So every component makes a TRPC call, or every component makes a few GraphQL requests. And this works, but it's not a good story, because performance is terrible. You have these water flow style requests where a request happens, and based on the response, you make another request. And you get a pretty bad user experience with all this jank. So you're like, hold on a moment, I can do better. I'm going to take these requests, and I'm going to batch them up at the top level. And well, okay, so now you have this huge request at the top level, and you've used some library like GraphQL request or Apollo to make that request, and you've gotten data back, and you're passing it down to your component tree using something like props. And if you're a little bit more savvy, you're like, hey, I'm going to take that top level query and refactor it using fragments. Well, all well and good, but the components still don't actually own the data that they want to fetch. You've just done a refactor. And why does that matter? Because let's say you have two components, A and B, that reference the same data that was fetched. A developer comes along and modifies component A, let's say removes the field. He goes to the root query and removes that field from the root query. And there's this implicit dependency that component B has on that same piece of data. And now component B is suddenly broken. And it's these implicit dependencies that really cause a lot of the problems. Also, if you have this top level query that's this huge unwieldy query, it's quite difficult to optimize that query. So you're going to have a lot of duplication, you're going to have a lot of overfetching, and that's just bad for performance overall. And then you have server-side React. Now this is actually a little more promising, but as soon as you get into building rich interactive applications that are client-side based, you often run into the same issues again. So what do we do? The developers are swimming in this spaghetti. The smart ones who are using fragments are taking the spaghetti and heaping them up into little piles. But nobody really wants to work with spaghetti. We want to work with the ravioli. We want components. So what does that story look like for data fetching? And the Facebook guys who gave us React and GraphQL, they actually already solved this problem. It's called Relay. And here's what a component tree could look like. Let's say this is the app we're building. You have a post list, post item, and each post item has likes. This is the code that actually makes that happen. So you can see that you have the post list component, post item, and likes. And with every component, you have the data that the component needs right next to it. So data fetch is co-located with the component. The next thing you see with the arrows is that the component tree is actually mirrored by the fragment tree. And if you notice the underlines, Relay does something very interesting called data masking, where it says if a component has explicitly asked for some data, only then can the component see that data. So a component can't actually access the data that some other component has fetched, which totally removes these implicit dependencies and removes that brittleness from the application. So, all right, fine. Each component has defined its data requirements right there. And then on top of that, the Relay compiler comes along, and the Relay compiler actually looks at your whole application, which is all the fragments, all the queries in the entire application. And the Relay compiler goes ahead and builds a minimum set of top-level queries to actually run the whole application. And since it's done at compile time, it can actually do very good static analysis. So it can do things like deduplication. It can look at dead paths and prune them. And what you get is an unbeatable performance for the whole thing. Also cool is that now developers can actually begin to own a little piece of the application. They can begin to own a component. So even as your application grows, even as your team grows, you can still continue to iterate with a lot of confidence and continue to iterate quickly. And the user experience also, well, it's great. So, all right, React came along and sort of revolutionized the way we do front-end development. And Relay, to me, looks like that new paradigm for data fetching, because Relay is the only thing that really solves all those problems. It's the only thing that gives us a component type way of doing these data fetching. And not adopting this, I believe, sort of holds us back. A lot of teams face very similar issues. A lot of teams speak to the same issues when it comes to scaling their UI teams. Everyone who talks about Relay, everyone who's used it is like, hey, Relay is the best solution, but building out that GraphQL server manually is not fun. And so at Hasura, with version 3, we're sort of building out this automatic way of having a Relay API on top of any data source or remote function without writing your manual resolvers. Here is a client that I'm hacking together. And this is sort of based on a little bit simpler version of the Relay spec. Specifically, connections are simplified. Please join us on hacking on this. Also of interest is the recent Figma AI conference, where they sort of looked at, there are several talks that look at how to use AI to automate a lot of the UI development. And to really get those automated tools going, I think we need really good abstractions. And this component way of fetching data looks like a really, really good abstraction to me. And that probably gives us a really strong foundation to actually build automated tooling on. The Hasura booth is right outside. Please come and share your experiences with scaling out your UI and UI teams and what problems you faced. I'll see you guys around. Thanks.